Bismillah ar-Rahman ar-Rahim. The students here, actually we are going to make our basically our own header files, but first of all let us discuss about this new header file style. Okay, that's iostream, and I'm not writing .h, but if you go to the old style, that's saying iostream.h. What is basically happening is by not writing .h, it's actually the newer C++ stuff, wherein it's a modern style headers defined by the standard C++. Now modern C++ actually do not use .h extension. What does that mean is it is actually telling the compiler to use this standard library. That's namespace, standard namespace basically. So what happens in the standard namespace is actually this namespace is also a recent addition to the C++. Both of these, new style header and namespaces, these are actually the the ANSI C++ standards. Now these namespace actually are what they are actually they help in organizing actually large programs. It creates a region basically. It's a region wherein you put up all the declarations there. So it's a declarative region basically, in which various program elements can be placed. So if you want to find something, and in this style, when we have no namespace, basically everything is in a global namespace. So wherever, if you say cout, it will be in a global namespace. So that means you cannot rewrite the same stuff, say same name for any other thing, because that will create a problem, name problem. So but if you have a namespace is like this, you can create your own namespace, and anything pertaining to that, only thing is you resolve namespace by putting up that std. For example, here if I don't use this and I have to use cout, basically I have to tell him that this cout basically belongs to std. Okay, this is what we do. But if by putting up namespace here using a keyword using, we're actually putting up the global namespace. That we are putting this namespace as global. That means everywhere some thing is to be found, like what is cout, what is other things, it will be found in the std namespace. But if you do not want everything to be accessed, so you don't use this, but use whatever you want to access, only put up std there. So this is one thing. Second thing is how we make our own header file, so that because in maximum times in C++ what we do is we reuse a class. Okay, so class reuse, how we do that? When we make our class in a separate file and then link it with our original file, right? Say for example, this is our main file. Okay, and I will save it somewhere. So maybe I will save it on the desktop, on some folder. Maybe I call it on the desktop. I make a folder. What's happening here? Not clicking me anywhere. Say new folder. Why don't I click here and I say it my C++. Okay, and I'm storing it there as a file name, like this is a main file, main.cpp. okay, so this is my main.cpp, which happens to be in the folder my cpp. Now I create another file. Okay, and here I will create some classes. Okay, now I will say right click, code template, C++ template second. But the thing is that I can't have two main files. Look, this is my one of my main files which has the main. I will control it from here, but the next file should not have a main file. Okay, it should have only the classes. So I may not need this also. Maybe I will put up a some class, or I need this control V, because okay, now maybe I have some simple class, like I have a class, call it something, maybe that is because I'm this time around I make a very simple class to make you understand. Later on you can build your own classes where you can work out. Maybe I have a class display only, very simple class, right, which displays me something. And in the private part, maybe I have something, say int data, and in the public part maybe I have some functions in it. Okay, maybe a constructor of display, which basically constructor of display, right, which basically does what, which prints me the things. I would say cout and L, um, and print the data, right, and maybe again then L, right. And there may be some functions also which actually initializes the display function, maybe void set data and get data, void set data, which actually gets it int, maybe the data is integer type. Okay, so like int maybe a, then actually inside we do what, we initialize the data with this a, we say data equals to a, and also we need some, for example, get data function. Okay, I will copy this here and paste it here, and but I say void get data, wherein I will do what, I will see out the data like this, right. So I have a class which has the data part and some functionalities. Okay, and now I will save this as file save as, and I will not store it as a CPP, rather I say it maybe display dot h. Okay, in the same folder my CPP, that's important, so I have saved it. Now I want to use this class in my main.cpp where I have the main function. Okay, and first thing to do in this class is to create actually call that header file. So I say hash include, because I have to tell compiler that I need that class hash include. Okay, but don't put here the things in the angle brackets, rather say into the double quotes. I say that was display.h. What this angle bracket, and what's the difference between these two? The thing is that this one basically does what? It tells compiler that this header file is in a current directory. When there's a double quote, compiler starts finding the same directory where your file is. That is my, which one? That's on desktop. Let me go to the desktop. Okay, what's the name that? My CPP. It's in this directory. Okay, in which the main.cpp source file is. It will tell compiler to find the file in the display.h. But if you use angle bracket, it means it's the part of the C++ standard library, where it's a part of C++ standard library. Okay, so this is not a part of C++ standard library. This is actually we have done it, and I have put it where I have to tell him I will put it in the same directory where my source file is. Okay, so double quotes means find it there. Okay, and one more thing, is actually the preprocessor who actually starts finding the file in a current directory. Okay, so where one more thing. Now by this what actually happens is your later on when you link this program, the header file is linked separately, as compiled separately, and this file is compiled separately. Then later on they are together linked. So we are in a position here to actually create the objects of our class, which the name of that was actually what? Display, right? The name of that was display. Okay, so I can say of type display, make an object called ob1. Okay, and are we sending something to it? No, we're not sending anything to it. Okay, but when it tried to actually and the data, because data has nothing in it, so in the constructor I will say data equals to 0. Okay, okay, so I'm creating object 1, and then ob1 dot I can say set data and send something to it, maybe because in this set data I pass it with this one argument, so I pass some value from here, maybe I pass 34. Okay, okay, ob1 dot set data 34. Similarly, you got ob1 dot get data later on to print it out. What is that 34, right? Okay. Here we have a little problem, rub it out. Okay. Now I have done little changes here. Oh no, not this one. Look at this. I got here the header file. What I am putting up here a constructor. It says in constructor and data is 10, and then outputting that, then set data and get data, as we know. Then the main function here is calling my creating the object first. So when the object created, it calls the constructor. So what happens, because display.header file will be, when you compile this, actually it will compile separately this display.header file as well, because it includes preprocessor, include it and compile it, and then after that it will be linked together. When it will link it together, then it will be able to run. So display ob1, basically it will call the header file, it will call this constructor here and initializes data with the 10 and couts that. Then I'm calling set data, sending 67, and get data will get it down. That's 67. You can see in constructor 10 and get data 67. Right? This is how basically we created the header file. But the thing is that this display.header file is just a what is this? This is just a text file. If you go here, my CPP, where is that? My CPP. Here we go. And anybody open this. So basically, you will not give the main.cpp to anybody, right? You will not give it, because this will be the source file. You keep it off, but you will give the main.exe to someone. But you have to still give display.h, because without display.h, this main.exe will not work. If we cut it and I put it here, I paste, okay, and now you are trying to, it's not available, okay, whatever it is. Windows P, you try to run it. Let me first save this thing. What? Oh yeah, sorry. What I'm saying is this will run still, because its executable has been made. I'm sorry, a little bit I get wrong information. Because executable is in the main.exe. It has everything. It is a linked file. It is all things linked. But you have to because for reuse, we wanna reuse the stuff. So when you reuse the things, you have to provide with that. What is that? That file, which is called as display.header file, right? You have to give it to the people so that they can reuse it. But what things is, we do not want to show people what it is. Say for example, I will open it with the notepad. Now in this thing, the header file, when I give the header file to the people, I do not want that people should see the implementation. They should see what this do, but they should not see the implementation, right? So we have to separate implementation. So we're gonna separate interface from implementation. I will give only the interface so that people understand that what this function should do. That this has a set data, it says get data, you have to pass something. The constructor doesn't have a value, or tomorrow you may have some value you pass in, how many values you pass in, and what set data is having this much of value, or it returns what else. Yeah, that means prototypes. You have to tell people about the prototypes, what this actually class does, what this header file does. But you should not give them the implementation. You give the people the object, you give them how what it does, but you will not tell them how it actually works inside, right? So that means is we have to remove this stuff from here and put up only prototypes. So separating our implementation, from the interface. We'll do that in the next program. And here what I'm saying is we have to put up only interface, like your television. It has buttons. Okay, you press buttons, means that buttons will tell you actually what this television do, but how they do, they will not give it you that information, right? So anyway, you have mobile phone. A mobile phone will tell you how the buttons on that work, but it will not tell you how actually it will work. It will tell you what functionality, not how. So you have to remove the implementation from interface. That will be better software engineering phenomena. So that's all for today. Masalama.